Hi,
Good afternoon.
Hi.
how are you?
Doing good?
Good, good.
Very good. So let me see something before starting. Uh, uh, I saw yesterday night that many of you have not ended the last part of the unit. So I decide that we are going to make a quiz that will cover only half of the unit 3, and the other half we will make a new quiz for the other half on next Tuesday. Is that okay for everybody?
Yes.
Perfect.
That works,
Yes.
Professor. But
Yeah, that's fine.
what happened with the test?
Sorry?
What would happen with the test then? Because the test was supposed to be next Tuesday.
Yes, the test from today, I'm going to post it in a few hours.
No, like the test that was supposed to be next Tuesday. We were gonna have a test next Tuesday.
And the Tuesday's next test, well, maybe we will do it on Thursday. Maybe we will do the quiz on Tuesday and we will make the test on Thursday. So maybe
Okay.
we will do like this. We'll see. We'll see how we can advance. I want you to walk in a safe floor, to walk
Thank you,
bit
Professor.
by bit and to get the knowledge that you need, okay?
Thank you,
So
Professor.
I'm not making a big pressure, but please do not sleep. You can get things if you work continuously with discipline. You will go very, very far. You will arrive very far if you walk every day a few steps. If you try to walk many steps in one day, you will not get it. You need to walk slowly with knowing what you are learning, step by step. So we go step by step. So today we are going to review something from the last part of Unit 3, maybe, and we are going to start with Newton laws. So what I want to review from Unit 3, I want to review, for example, let's go to review two things, two basic things. Let me share my screen, sorry. Let me share my screen. Just a moment. Okay, so we are going to review two kinds of problems. The first kind of problem is projectile motion. And the second kind of problems is circular motion. You will see how easy it is to analyze this if you have the concept clear in your mind. So we go first with projectile motion. So this is the problem. You have an object. Maybe you throw from some height and you throw the object with some vector velocity that makes an angle alpha or theta, whatever you want to call. So the vector v has two components, v0x and v0y. What is the magnitude of the vector v? Let's say that the magnitude of the vector v is 10 meters per second, or let's say 50 meters per second. And let's say that the angle is theta. So what is V0x? V0x will be the magnitude of V by the cosine of theta. What will be V0y? The magnitude of V by the sine of theta. If the magnitude of V is 50, this will be 50 cosine of theta. If theta is 30 degrees, this would be 50 cosine of 30. So on here will be 50 sine of 30. So the problem is, you have an object. You launch the object in the presence of gravity. So the space is full of gravity. What it means is, it means that the gravity, that is an acceleration, will change the vector velocity. In what way? This is the initial vector velocity, v. The gravity will act and will change the vector velocity. So the acceleration is the change in the vector velocity per unit of time. So the change is simple a, the change, you can see, the change is simple a by d dt. Is correct or not? So the change is simple the vector g by delta t, because the acceleration is g. So we want to study what happens if we throw a projectile in the presence of a space where it exists g, exists the vector g. So the vector g is pushing the vector v, g by delta t is the change in the vector velocity. So the new v will be like this. So you will write this equation, v final, this v final, equal v initial, this v initial, plus the change. The change is g by delta t. So what happened with this projectile? This projectile is subject all the time to a change in its vector velocity. It starts like this, like v, let's say 30 degrees. Let's say the magnitude 50. When the time passes, g will act, and the vector g is going down. But what will act through v is not g, it's g by delta t. So this will be the change in the vector velocity. So the new vector velocity will be like this. When the time passes, the accelerate. There is someone talking here. Let me see if I can make a silence. Let me do it here. Let me see how to do it. Sorry, what is the? Sorry. Ah, here. Okay, now we can stay better. So, the initial velocity v is this one. This is the initial velocity. So the magnitude of v will be 50 meters per second. So g will act, and when I cannot sum v with g, I cannot sum v with g, because g is acceleration and v is velocity. But I can sum g with delta t, because g with delta t is change in velocity. G with delta t is change in velocity. So the final velocity will be the initial velocity plus the change. And again, the g will act for another time, g by delta t. And the vector velocity will change. And this will be the new vector velocity. As you see, the vector velocity starts like this, and is in some way is rotating is rotating like this. So the movement, when you throw, is like this. It starts like this one, this vector velocity. Later will go like this one. Later will go like this one. And later will go like this one, horizontal. And the V0x remain constants for all the vector velocity. You see that the change is here. So cannot change in x the velocity. It changed only going down the vector v. Do you see this picture? So the idea is to write the equation of movements for this case. How do we write the equation of movement? So we write the equation of movements as always. This is not a new problem. This is what you have already studied. The equation of movement are like this. Ay is minus g. What is ax? The component of the acceleration in the x direction, ay is like this. But ax, how is ax? There is acceleration in the x direction. This is x and y. There is something accelerating in this direction or make it to decelerate in this direction. Well, if there is a friction force, there is acceleration in this direction. The object is slowing down the velocity because there is friction. But in this kind of problem, we do the problem without friction. So the acceleration in the x direction is 0. So my question is, for avoiding that the acceleration is 0, what is the velocity Vx? So
Professor, can I ask you a question?
Sorry?
Can I ask a question?
Yes, of course.
So when you say that AX is 0, that's because you said that there is no friction?
It's not only that there is no friction. What I said is that the object will be launched, and I know it will do a parabolic movement. He will be down in a field that the acceleration will go down. G will go down. So if G will go down, who will accelerate in this direction? In the x direction? Nothing, there is nothing. If G will do like this, so there is acceleration in the x direction and there is acceleration in the y direction. But G goes down. So the acceleration is going down, cannot change in the x direction. You see, V is here. If you make acceleration G by delta T here, B final will be like this. So the component in the x direction never change. You catch the idea?
Okay, thank you.
It's a very important idea. So the idea is that there is no acceleration in the x direction because all the acceleration that you are in this problem is in the y direction. So if the acceleration is in the y direction, it will change v sub y, but it will not change v sub x. Okay? And these pictures say clearly why Vx will not change if the acceleration goes down. So we are going to write the equation of movements. Once that we write the equation of movement, the problem is solved for any case that they put you, the problem is solved. Yes?
So the reason why it's y is because the ball, like if this is a ball they're kicking, the ball is going up and then down.
Yes, the body is going up,
Then, yes.
up, maximum height, and going down, down, down.
So that's why it's negative g.
It's
negative g when it's going up.
It's negative g because the Negative G is
The
because
gravity is forcing it down.
Y is going in this direction. And G is going in the opposite direction.
Okay.
So this is the vector J. This is the vector I. And the vector A, the acceleration, have the magnitude G, is in the J direction, but it's in the minus J direction. It's going in this direction, the acceleration. So the acceleration is making that if the velocity is like this, V, the new velocity will be, after some time, G by delta T will be like this. So it means that initially the velocity was like this and has two components, Vx and Vy. It was the initial velocity, Vx and Vy. But the final velocity will be like this and have two components, Vx, and now Vy has changed. You see, when he's going up, the Vx will not change, but the Vy will decrease. That's why the vector V will do like this.
The Vy increases?
No, Vy decrease.
Okay, yes, okay, got it.
Vy is what's like this, and now
Oh.
only like this. So when he moves, the Vx maintains his velocity because there is nothing in the x direction trying to make it bigger the Vx or smaller the Vx, but the Vy is becoming, it starts like this, the Vy. After some time, Vy goes like this. After some time, will go like this. After some time, will go zero, like here. When B is here, the Vy is zero. After some time, the Vy will go down. You see, it will go like this, the V, but the Vy will be like this. So the Vy will go down, will go down, will go up. Okay? You catch it or not catch it? Or do I?
Professor, in that chart that you're doing right now,
Yes.
what it's on an X and Y axis, or is it Y and T?
Yes. X, this is X and Y axis. And for the
Okay,
acceleration, AX is a constant acceleration and it's zero. AX is zero as a function of time, and AY as a function of time is constant, is minus G. Minus 10, let's say. Oh, gracias, mi vida. Okay, so let's go to write the equation of Buchmann for this object. So we have AX equals 0. If AX is equal to 0, Vx can change. If AX is equal to 0, no acceleration.
So there's no
Change.
change.
There is no change in velocity because AX is change in velocity in the x direction per unit of time. If this is 0, means that change in velocity is 0. This means that Vx final equal Vx initial. So if Vx final is equal to Vx initial, means that Vx is constant. So Vx means that it's constant. So if the acceleration is 0, Vx is constant. This implies that Vx is constant. What constant? Well, if I start throwing the vector V like this, well, I will make the angle theta, and I will find that Vx is the magnitude of V by the cosine of theta. Or in our case, it will be 50 by cosine of 30 maybe, if the angle is 30. So Vx is this quantity, and it doesn't change when the object is moving. So this is the Vx. So we have found the equation of movement for the x direction. So for
Professor, what section is this for?
projectile movement, or maybe I call it in a different way, parabolic movement, maybe. Okay? Yes?
Yeah, thank you.
Okay. So, for the case.
Oh, it's called the parabolic trajectory?
Yes.
Okay.
Because in this case, the trajectory will be a parabola. So for the case AX equals 0, this implies that BX equal constant, and this implies that BX have to be V0x, and V0x have to be magnitude of V by cosine of theta. Okay? So have we solved the equation of movement for this case? Or we need to write down another equation of movement? So as I explained you, the equation of movement means that you know what is AX at any time. I know that AX is 0 at any time. You know
Professor?
what is Vx at any time. We know what is Vx at any time. It's the initial velocity. And the equation of movement is that you have to know what is
A and delta t?
x of t.
Oh,
And what is the equation of movement? Is V0x is constant. Is initial velocity plus the change. And the change is V0x by t. This is the change in position. So x of t is initial position plus V0 cosine of theta by t. So with these three equations, we have solved the problem in the x direction, only knowing this data, ax equals 0. So let's go to write the equation for the y direction, okay? So this is the equation that we use in the x direction. What are the equations? I repeat, the equation are that ax is 0, and because ax is 0, Vx is constant, and because Vx is constant, should be the initial velocity. But the initial velocity V0x, when you throw the ball, should be the magnitude of V0, the magnitude of V0 initial, by cosine of theta. Correct or no? And the second thing...
Is that the magnitude of the vector velocity initial?
Is
okay.
Correct, is correct. Is the magnitude when you throw it, the ball, when you throw it, the ball or whatever you throw, this will have a magnitude, V0. And the magnitude of V0 cosine of theta will be V0x. And V0x is this one. And this one will be constant. This magnitude will be constant. The other Vy is the one that can change. So we have the equation of movement for x of t. X of t is the initial position. If x0 is 0, like in this case, you will put a 0 here. But if x0 is not 0 because you throw from here, well, x0 will be this initial position, okay? Plus the change. But the change for an object that is moving with constant velocity is v by t. In this case, v0x by t. So, because v0x is v0 cosine of theta, the equation of movement for the x will be, I write it again, the same equation will be x of t equal x0 plus v0 cosine of theta t. This is the equation for the x For the Vx will be V0x, or magnitude of V0 cosine of theta, and for the Ax equals 0.
Professor, what's the difference between when you wrote the equation for x of t equal to initial x and then v0 cosine theta t, does it matter if we put the magnitude symbol there for v initial? Or is it like the same thing?
No, it's better if you put it. Okay? The magnitude.
Okay, thank you.
Microsine. So,
Professor, when would we use this equation, this red equation?
Yeah, Professor, because I think some of the trouble that we've had is like you in the video you posted, like there's like one equation, but like we know that there's a lot of other different equations. So like we're confused on when we should, like when to use each equation.
very clear. You will use this equation always, that Ax is 0. Always. Because if Ax is 0, there is no acceleration in the x direction. And if there is no acceleration in the x direction, there is no change in velocity in the x direction. So the x will be the second equation.
For the homeworks, there was questions where we had to assume that the gravity was, I think, negative 9.8 is what they tell you to assume.
Yes, I didn't understand your question. In the problems?
Yeah, like some of the homeworks, there's a specific, I think, number where it's negative 9.8 for gravity.
Yeah, what about that?
Some of the problem, what? Can you repeat it?
Yeah, like some of the problems on the homework, in the video that you put for free fall, you didn't say that we had to use that number. It was negative 9.8.
So you're like asking.
Use negative 10. It's the same thing.
Okay, thank you.
Okay. Why to use negative 9.8? If you can use negative 10, it's almost the same thing, and you don't care about using calculators. You can do it by using your head, and you don't lose the focus of the problem. So now we have three equations for the x direction. Let's go to find the three equations for the y direction. So I think I'm not connected. Let me connect it. I think I'm not connected. Do you see my screen now?
Yeah.
Yes. Now, the first equation for the y direction, so this is for the x direction, for the x. Now we are going to do the y direction. So, what is ay? Ay is the acceleration in the y direction. What's the value of the acceleration in the y direction? Minus 10. Or minus g, if you want to write. It's the same. Let me write minus 10 better. So we have an acceleration that is minus 10 meters per second squared. What it means, this acceleration? It means that in every second, the velocity will be diminished, will not increase, will decrease in 10 meters per second. So the acceleration of minus 10 meters per second means that if you start with this velocity v0y of 100 meters per second, after 1 second, your velocity will be 90 meters per second. Why? Because the acceleration is minus 10. So minus 10 by 1 is the change in the velocity. So you will have, and after another 1 second, your velocity will be 80, will be 70, will be 50, whatever. It will go down the velocity. Why? Because the acceleration is negative, minus 10. So my question is like this. If the acceleration is minus 10, can you tell me what is Vy of t for any time? Anyone can tell me?
Say it again, Professor. Ask it again.
I repeat my question. If the acceleration is minus 10, can you tell me what is the equation for the Vy of t?
Is it v initial minus
Sorry, V?
v initial minus gravity by time?
Of course, because it's saying that if your velocity is 100, your initial velocity, after 1 second, 10 by 1 is 10. 100 minus 10 will be 90.
And is that finding the
if 100 and 2 seconds has spent, 10 by 2 will be 20. 100 minus 20 will be 80. So your velocity is decreasing because this star is minus 10. So this is the equation for the velocity. Can you tell me what is y of t?
Professor, I have a question for the y of t, Vy of t. Why would it not be V initial, the magnitude of V initial times sine of theta?
Magnitude of V by sine of magnitude of V0 by sine of theta minus 10 theta. This equation is the same that the other equation. Okay, because I wrote V0y like magnitude of V0 sine of theta. If you prefer to use this equation, this side of the equation, you can use it. If you prefer to use this equation, it's the same one. It's just I put V0y as V0 sine of theta. Okay?
Professor, is AY always negative 10 or can it be positive 10 sometimes?
Well, it could be positive 10 if you do like this. If you, for example, you use the y is like this. This is the y of t. But imagine that you decide to use the y like this. If you decide to use the y going down, so the acceleration go parallel to the y. So can be plus g if you use this system of reference. Can be also plus g, but we measure things from the floor. So the y is like this and the g is going like this. So use this criteria, or if you want to use this criteria when the y is going down. So this is the projectile, the y, you measure the y from here, y, so the g in this system of reference, ay will be plus g in the direction of g, okay. Of course. Okay, and the y will be increasing when this move. The y, when you launch the velocity v, the y will be always being bigger and bigger and bigger. In our picture, the y grows up and going down. Well, if you do it like this, and you launch with this velocity, the y will be negative because the positive y is going in this direction. It will be negative, negative, and later will be positive and positive and positive. So I would say, don't be confused. Use these equations and use this system of equation where the y goes like this, and you will be fine, okay?
Okay, thank you.
But it's interesting to make it like you said. It's very interesting to make it like you said, because if you say like this, if you do it like this, it means that you are understanding very well. Sí, claro.
Lo tienes que buscar.
¿Cuál título?
El título de su clase.
Sí.
Lo tienes
El
que
de anoche, el de ayer, sí.
¿Cómo que el taller? El título de su caso. Ya pagó los taxes.
Ah, que se lo lleve a Jumbo, sorry. Que se lo lleve a Jumbo.
No, que si se lo tiene que pedir a Jumbo. Esa es mi pregunta. Sí, que
Mm.
tiene que ir a Jumbo a pedirlo.
Okay. So my third question, this is my first equation for the y. This is my second equation for the vy. And this is my third equation that I want to construct for the y of t. So y of t will be y0, initial position, plus the change. Can you tell me how much is the change in a situation where the acceleration is not 0, when the acceleration is negative -10?
There's no change.
No
the
change. Why? Oh, my experience say that if you throw something, y and t, I mean, you throw with v like this, and after sometimes the y0 here, the y will go up and will go up and will go lower and will go lower. So the y is changing. So what is the change in the position in the y of t? In the y is the initial position plus the change in the y direction. And the change in the y direction, if you can have seen my videos about constant acceleration. This is a constant acceleration of -10. This is the case of a constant acceleration of -10. So will be v0y by t plus 1/2 a t squared. In our case, the equation writing formally will be y of t equal initial position plus the change. The change in Vy is Ay by delta t, because Ay is simple delta Vy divided by delta t. And Ay is -10 delta t. So there is a change in the velocity, and the change is -10 times delta t. And I have made this picture to realize you that there is change in velocity, and when there is change in velocity, also there is change in the y, because the object is moving. How can you change your velocity in your car and your car is not moving? Can you explain me that? Not possible,
Yeah,
right?
not possible.
Yeah,
Okay.
it's not possible.
So the y of t will be y of 0, I'm here, y of 0, plus v0y by t. So I will write v0y like magnitude of v0 by sine of theta. Is correct? Plus, but instead of plus, I will write minus, because the acceleration is 10 minus 1/2 10 t squared. If you want to put 9.8 here, you put 9.8. I don't mind. So y of t, this is the equation.
Wait, Professor. Why would the V initial be equal to Vy in this situation?
Why this term, you mean? Why is this term?
Yeah, why is it there?
This term.
Yeah.
Because if it's a constant velocity, the y of t will be the initial position plus the change. And the change will be v0y by t. But the velocity is changing. And now the change is not exactly v0y by t. The change is v0y by t plus a term that indicates that the velocity is changing. And these things, these facts that the velocity is changing, makes you to run a space in a different way. So delta y is changing not only like if it's velocity constant, because it's not constant the velocity, the acceleration is making a game here, a play. And if you see my videos, you will see two different deductions of this equation, how I do arrive to this equation. And it's not so difficult, this equation. It's not so difficult to arrive this. So this equation is valid when there is a y acceleration. Okay?
Okay.
So
Professor, I have two questions. Can I ask two questions? Okay, for V0y, is that usually given in the problem?
Normally, they give you the vector v and the angle.
Okay.
They give you the magnitude of the vector v and the angle. Normally. So V0y, you can immediately get it.
What is V0y again?
Okay. It's a good question. What is V0y? I throw the ball at the ball or the projectile from this. This is V. Let's say that this is 100. Let's say that this angle is 30 degrees. Initially, I throw the ball like this. After the time pass, the vector V will change in magnitude, will change in direction, and will do like this. Okay. So initially, there is a vector velocity, a component V0x. Oh, and what is that? Well, it's 100 by cosine of 30. And initially, there is a V0y. Oh, and what is V0y? The magnitude of V by the sine of 30. So what is V0y? V0y is this magnitude, V0 sine of theta. So here is V0y.
Okay, so then the only difference, like we would use that equation when they wouldn't directly give us V0y.
We will use this equation if the acceleration ay is minus t. If ay is 0, you will use this equation, y of t. If ay is 0, you will use y of t equal y0 plus v0 sine of theta by t, because there is no acceleration in the y direction.
I thought that was when ax equals 0.
Right. If ay is equal 0, you will change the x for the y, or the x for the y, and this will be the equation that you will find. You will find
okay.
y of t equal y0 plus v0 sine of theta by t.
Oh, okay, so x and y are interchangeable there.
Right, but in this case, this is the movement that happened. It happened with ax equals 0 and ay minus 10. So from this initial condition, everything happened. This condition implies this condition. This condition implies this condition. So from this initial condition that ay is minus 10 implies that the vy have to change like this equation. And from this equation of vy, it implies that the y of t have to change with this equation. Oh, sorry.
So you have two different vectors, a curved one and a straight one?
You have two different vectors? What do you mean you have two different vectors?
Because you have one that's straight and then you have the other one that's curved.
You have one that is straight
No, I think the one that's curved, like the one that's going like in like a parabola, is just the vector. Yeah, you're kind of right. It's just the same vector, but it's going in a different direction. Because whatever comes up must come down. You know what I mean?
About what vector are you talking about? About the position vector, about the vector velocity, or about the acceleration vector? What?
Well, it had a V, so I assume it was velocity. And you had
Okay.
one that was going straight up, and then one from the same spot, but it was going curved.
Let's go to see this in vector analysis.
I think what that was the one that was curved was the position vector of how the ball was actually moving, and then the velocity like is tangent to the vector of position. So it would be like kind of a straight line coming off of any point on the curve.
The velocity is not tangent to the vector position.
Oh, it's not? Oh, well, ignore that then.
Let's go to rewrite this.
Sir, can I draw on the screen for a question? I think I know what she's asking.
Yes, of course.
I think what she means is like this, right? You have this. Ooh, this is crooked. And then you have this V. And then she wants to know what is like you drew something like this, like that. And she wants to know what's the difference if they're like the same or different vectors. Is that what you're asking?
Yeah.
Yeah, that's what I drew it like bad, but like I think that's what she wants to know. If it's like the same vector or if it's like different. I would assume it's different because one is going in the Y and then the other one's coming back down. I don't know. That's what she wants to know though.
Okay. Can you give me the screen? I will tell you the answer.
Yes, you can. I think you have control now. I'm done. I don't know.
Let me see. Let me see. How do I?
You might have to erase.
Oh, okay. Annotate clear. Okay.
Yes. Do I have my screen now? No.
I think so, Professor.
Let me. I don't know. What is the screen here? Share the screen. Just a moment. Let me do it. Let me do it just a moment. Oh my God. Now participants 66. New function here. I found it. Sorry, let me. Okay. Let me share my screen again. Okay, I know what you are asking. You are asking 3 questions at the same time. And let's go to answer the 3 questions at the same time. This is the object. The object is moving and will do this trajectory, but this trajectory is on the space XY. What it means is, it means that the observer that is here will observe the vector position initially like this one. When the object is moving, the vector position will be like this one. When the object is here, the vector position will be like this one. When the object is here, the vector position will be like this one. And what I have said is that the x will be x0 plus v0 x by t. And the y, this half of the vector position, will be y of t, will be y of 0 plus v0 yt minus 1/2 10 t squared. So one thing is the vector position. The vector position is moving like this. At any time t, r of t, the vector r of t, that is x of t, position x in the y direction, by plus position y in the j direction, the vector rt, if you want to see it at once, will be x0 plus v0x by t in the I direction plus y of t, y0 plus v0y of t by t minus 1/2 a t squared in the j direction. And you will have all this vector. If you draw this vector, you will have r of 1 second, r of 2 seconds, r of 3 seconds, and you can plug in numbers here and you will see the vector r moving. So this is the first question. The second
Does
question,
so XO and YO just mean like the initial one?
sorry?
X0 and Y0, those are like the initial X and Y
Of course,
coordinates?
of course, of course.
So then what would VO, like, is that the initial velocity?
VOX is the initial velocity in the x direction. And VOY is the initial velocity in the y direction. So I have said that if V is like this, you have two vector velocities. You have this with V0x, and you have this with V0y. And what I have said is that this is the angle theta. V0x will be the magnitude of V by the cosine of theta. And V0y will be the magnitude of V0 by the sine of theta. This is what I have said from the beginning. So
And V0 is just the initial velocity, or is it just to denote
always,
the velocity?
Always x0 means initial velocity. Y0 means initial position. V0x means initial velocity in the x direction. V0y means initial velocity in the y direction. A0x will interpret as the initial acceleration in the x direction. And A0y will be interpreted like the initial because it's the zero, always is the zero. If you want, I can put xi, yi, if you like, vyx, vyy, ayx, and ayy.
Wait, Professor, you said the Y0 is the initial position?
Yes, if I put the zero, it's initial position. If you don't like the zero as initial position, you put an I, initial. I equal initial. Equal at the beginning. At the beginning, okay?
Is X0 also the initial position, or is that something else?
X0 is the initial position.
So X0 is the initial position in the X direction, and then Y0 is the initial position in the Y direction?
Yes, and V0X, what it is?
V0X, you said, is the initial velocity in the X direction.
And V0Y?
Is the initial velocity in the Y direction.
What? It's so difficult?
No, it's a lot of variables.
Well, you have to, I have made a video, and this is the problem. I think I catch it the other day. I thought, why you don't catch it? Why you don't catch it? And I want you to see this video. Can I show you one video? Let me show you one video that you will enjoy a lot. Give me 1 second, please. 1 second. I'm going to show you what I mean exactly. Let me share this video. Let me share, just a moment, please, just a moment. This is very interesting because I want you to Oh, I want you to see this. This is a boy, okay?
5-year-old whiz kid Arden Hayes. Hello, Arden.
This is a boy. See this video.
Since you were here last, you've become very interested in geography, right?
That's why we have them.
That's why we have maps on the wall. So you know every country in the world.
And that does not have South Sudan on it.
That what?
That does not have South Sudan on it.
It's missing a country?
Yeah.
Where should it be? That should be South Sudan?
No, the blue country broke up into a southern half called South Sudan.
Oh, I'm sorry. I didn't know. You know what? I'm going to make sure someone gets fired over that.
Yeah, because the country broke up into two countries.
I know, it's ridiculous. You think everyone would know that.
But no one does.
But no one does, except for you. You know a lot of this stuff, and so I'm going to quiz you, and I want to start with an easy question. How many countries are there?
196.
That's exactly right. Well, we're going to show you some countries, and I would like to ask you to identify that country and then name its capital, okay? So let's go to the first one. And there's the globe, the world spinning.
Paraguay.
Paraguay?
Yeah.
Let me see. Yes, that is right. Paraguay. And what is the capital of Paraguay?
Asuncion.
Asuncion. That is correct. You're absolutely right. All right.
Okay, if you get any pronunciations wrong.
You said I pronounced it wrong?
No, I mean if you get any pronunciation.
Oh, it's okay?
Yeah.
Okay.
Yeah, because then I was like, concrete is actually gay, but some people think it's concrete.
Oh, I know. I've had fights with people over that. Let's look at another one and see if we can identify this country.
Yemen.
That is Yemen. Yeah, that is exactly right. How do you know it so fast? What is the capital of Yemen?
Sana'a.
Sana'a is absolutely right. All right. How about if I give you a capital and you tell me the country? Okay. Riga.
Latvia.
That is right. All right. How about Funky Town?
Oh, that's a joke.
Oh, that's a joke one. Yeah, that is right. All right. This is a tricky one. Let's go to.
Okay, this won't be a tricky one.
This.
It broke up into 7 countries.
Yes. What country was it originally?
Yugoslavia.
And now what countries is Yugoslavia?
Slovenia, Croatia, Bosnia and Herzegovina, Serbia, Kosovo, Montenegro, and Macedonia. Sometimes I get confused with Kosovo and Macedonia.
Wow. One more map, and do you know what these 7 countries have in common?
They both end with stan.
They all end with stan. That is right. What countries are they?
Kazakhstan, Uzbekistan, Turkmenistan, Kyrgyzstan, Tajikistan, yeah.
Unbelievable. That is exactly right. You got
Afghanistan, Pakistan. Hey, it appeared before I said Pakistan.
See that? Astonishing. You know, a lot of
together and make one big Stan country.
A lot of people call them Stan, Afghanistan and Pakistan.
Yeah, but they're not.
They're not. They're Stan. That's the right way to put it.
Yeah.
Hey, Guillermo, bring out the presents. We have some presents for you. I know you lost a tooth. What did the tooth fairy bring you? Huh? Oh, look at that. We got you.
I thought this was a real globe, but I also have a real globe at home.
Oh.
Thank you.
All right, well, I'll take that one back then.
No.
All right.
It's okay. It's just a puzzle.
It's okay. And what do we have here for you also? Oh, the Sony Xperia Tablet Z.
Well, yeah.
What's that?
Give it away because I'm going, but we're just planning to get an iPad for Christmas.
Oh, you are? Okay. I'll take these both in. Arden Hayes, everybody. Thank you. Great job, Arden.
So why I want you to show you this video? Because do you think that this boy is memorizing countries? Of course, he needs to memorize something, but he's making relations. The capital of Spain is Madrid. He's making a relation between Madrid and Spain. But in the map, he's doing also another pattern recognition. You show him the shape of one country and he recognizes the country. So why I say this? I say this because you have to develop pattern recognition. And you don't have only to develop pattern recognition. You have to educate yourself and the kids that you will have to develop and to be able to make pattern recognition. When they see a picture of y of x, like this. This is the picture of y of x. Okay, y of x equal, let's say, sine of x squared plus 5x. Well, if I make x of t, and I make the change x, I call it y, I will call x. And t, and the x, I will call it t. If I make this change, the equation x of t will be sine of t squared plus 4t. And this equation is the same equation in the variables x and t. If I draw this picture x of t, will be exactly the same picture, the same function. So you have to develop pattern recognition all the time. And pattern recognition is the most powerful method to understand things, to create theorems in mathematics. Pattern recognition is what makes you to see things that it looks different, but are the same.
Professor,
So,
what does that say? Is that a cosine or a sine?
This one?
Both of them.
Well, it's sine and sine.
Okay, I couldn't understand the handwriting.
Well, I see sine. I don't see cosine. Cosine. I see very different sine and cosine. So maybe this is your challenging. The challenge is to understand my handwriting. Maybe it's this one. But for the question, I can guess that is a question that is not important. As I wrote here the same thing that I wrote here, the pattern recognition is the same one. So your question is a question that that will not clarify you anything. If I wrote here cosine of x squared, and I write here sine of t squared, this is something different. I made a mistake because this is not pattern recognition. I cannot put the same thing in different variables, okay? So let's go to see what is important in this subject. Let's go to our subject. So our subject is this one. We have the dot first, the equation of Bumba for x of t. X of t is x0 plus v0x by t. Y of t is y0 plus v0y by t minus 1/2 10 t squared. The second set of equation is vy of t, v0y minus 10t, minus g by t, and vx equal v0x equal constant equal v0 magnitude of v0 cosine of theta. So, and the third set of equations that is from where the equation 1 and equations 2 comes is that ax is 0 and ay is minus 10. This is the truth. So let's go to apply this equation for a particular problems and see how the problem works, okay? So this is the problem that I want you to do. So this is the problem. Did you write these equations in your, do you have this equation?
V0 is the initial velocity, just the regular initial velocity.
V0, this one, is the total initial velocity. V0x is the total initial velocity of the x direction. V0y is the total velocity initial in the y direction.
Okay, thank you.
Okay, so these are the three equations that we are going to use to solve problems. What kind of problems? These kind of problems, the problems where ax is 0 and ay is minus 10. What happens if we want to solve any other problem that ay is minus 20? Well, we will put here minus 20, we'll put here minus 20. Okay? Okay, let's go to solve this kind of problem. So, to solve this kind of problem, we do an example. Okay. Find x of t, y of t, vx of t, and by of t for a projectile that is launched at x0 equal 2 meters, y0 equal 5 meters, v0x equal 10 meters per second, v0y equal 20 meters per second, ax equals 0, ay equal minus 10. Can you find the equation of movements for this case? So the problem is like this. You have the x and the y. This is the x and the y. You will launch from x0 equal 2 meters, and 5 meters in the y direction. 1, 2, 3, 4, 5. You will launch from here. And you will launch a projectile that have in the v0x 10 and the v0y 20. So you will launch like this. This is the velocity. Okay, this is the velocity. 10 and 20. So you will launch. So the projectile will do like this. Okay? So I want to find.
What is y0? You wrote over it. I don't know what that is anymore.
No, you are joking.
5 meters.
5, thank you.
Y0 is 5 meters. Okay. Oh, I thought that you are asking me what it means y0. So, okay, so what is the equation of movement for the x of t? X of t will be x0. What is x0?
x0 is 2.
Thank you, 2. Plus v0x. What is v0x?
10.
10. 10 by t. This is x of t. What this equation is saying? That x of 0 is 2 plus 10 by 0 is 2. It's true that initially it is 2? It's true or not? It's saying also that x of 1 is 2 plus 10 by 1, 22. It's saying that x of 3 is 2 plus 10 by 3, 32. Okay, I have x of t. This is my equation for x of t. The object have launched from this position, and when it happened 1 second, the object is at 22 meters from the origin, 22 meters. So it has advanced 20 meters. 20 meters is the distance that he advanced. but the position is 22. So the object will be here. And the y, where it will be the y? Let's go to construct the y of t. Y of t equal, what is y0? So I'm going to apply this equation, y of t, well, I write it down. Y of t equal y0 plus v0 yt minus 1/2 of the acceleration by t squared ayt. So let's go to, so I already found x of t. Oh.
Professor, I think you made a mistake. Isn't 10 times 1 plus 2, 12, not 22?
Sorry, x of 2?
Oh, okay.
Or x of 1? X of...
You wrote x of 1, but then you calculated it for x of 2.
Sorry. So x of 2 will be 2 plus 20 plus 10 by 2, 22.
So the other one should be 12.
Yes, x of 1 should be 12. Sorry, 12.
Oh, okay, thank you.
Every second, 10 meters. Every second, 10 meters. This is the velocity, 10 meters. Okay? So y of t will be, let's go to find y of t. What is y of 0?
Five.
5, thank you. Plus v0y. What is v0y?
20t.
20 by t minus 1/2. If ay is 10, 10 divided by 2 is 5. T squared. So this...
Oh, and this is when you use the quadratic equation, right?
No, I have not used the quadratic equation.
That's
This is a
equation of
parabola.
motion.
This is a parabola on y of t. And you can use the quadratic equation if you want to find at what time t y is 0. At what time t y of t is 0. Yes, you can use the quadratic equation, but this is the equation of a parabola in time, not in x, in the time. So what it says this equation? It says that if you want to find t at 0 seconds, y of 0 will be 5 plus 20 by 0, 0. Minus 5 by 0, 0. Y of 0 is 0. It's true. The projectile was launched initially at y equal 5 meters. What will be y of 1? So y of 1 will be 5 plus 20 by 1 minus 5 by 1 squared. So y of 1 will be 25 minus 5 will be 20. So means that at 1 second, the object is at 12 meters here, at 12. He had advanced 10 meters, and in the y direction, he is 20 meters up. So the position will be this one. What happens if I leave the times pass? If I leave the time pass, x of 3 will be 32. So the object will be here, 32, in the x. And in the y, I will find y of 3. Y of 3 will be 5 plus 20 by 3 minus 5 by 3 squared. So how much will be y of 3? Will be 5 plus 60, 65 minus 3 squared is 9. 9 by 5? 45.
Can you scroll down a little bit, Professor?
Oh, yes, sorry.
Where did you get the 20 from? From the graph?
This one, this 20?
Yes.
V0y is 20.
Oh, yes. Okay, thank you.
So V0y is 20. Okay. A is 10, but 10 divided by 2 is 5. Okay. So
yeah.
So I'm calculating y of 3 for this equation. For this equation, I'm putting the time t equal 3 20 by 3 will be 60, 60 with 5 will be 65, 3 squared will be 9, 9 by 5 will be 45, 65 minus 20, 45, it will be 20. So y of t is 20, and x of 3, I have calculated here is 32. So means that the projectile at t equal 3 seconds is at the position 32. This is 32, and the height is 20. So the projectile will be at this position. But to describe the state of a particle, we also need the vector velocity. We know the position at any time. We know the x at any time, and we know the y at any time. Why we know this? Because we know the equation. These are the two equations. So let's go to find now the Vy and the Vx. Okay. Okay. So for the Vx, we have Vx equal V0x and Vy equal V0y minus G by T, 10T. This is my equation. Let's go to write my equation in the context of the problem. In the context of the problem will be Vx equal V0x. But V0x, we said that is 10. So Vx is always 10 meters per second. Whatever is the object you see here, Vx, this will be 10. Wherever it's the object here, you will find the Vx will be 10. Never change this quantity, never change this velocity, this component of the velocity. So what will be Vy? Vy will be V01. Can you tell me for this problem how much I said that is V0y, the starting velocity in the y direction?
20.
20, thank you. 20 minus 10t. So now for this equation, I will find Vx at time t equal 1 second. So Vx at time t equal 1 second will be 10. Why? Because never change is 10. And Vy at time 1 second will be 20 minus 10 by 1. Will be 20 minus 10, will be 10. So the velocity has decreased. It was 20 and now it's 10. So the velocity is going down. So I know that at t equal 1, at t equal 1, according to these two equations, according to these two equations, Vx is 10 and Vy is 10. At t equal to Vx, it keeps to be 10, but Vy at t equal to will be V0y, 20, let's go to do it here, 20 minus 10 by t. 10 by t is 2, 20 minus 20, 0. So Vy is 0. So I will write down 0 here. So at t equal 1, Vy is 10 and Vy is 0. Can you guess what is the object at t equal 2 seconds?
Is it on the floor?
No. The object is here because it's moving with Vx 10 meters per second and Vy is 0. When the object arrives here, Vy, when it arrives to the floor, the Vy is negative.
Oh, okay.
So this t equals 2 seconds is this position when the object is here. So conclusion, these two equations will say the velocity at any time t, the components of the velocity at any time t. And these two equations the x of t and y of t will tell you the position at any time t. So you have control of the problem. Anything that will ask you the problem, you are able to solve. For example, let me solve questions. If I ask you like this, so let's go to write this equation in a new page. Can you tell me to this equation now? I'm going to ask you on this equation. Okay.
Professor, can you go down a little bit? I didn't finish writing the notes.
Yes, I can do it. For you, I can do it. For other, no, only for you.
Okay, thank you, Professor.
I'm joking. For everybody, I will do it. Okay, so now let's go to play with this equation to obtain result. I'm going to ask many things that we can deduct, that we can play with this equation to obtain result. What kind of result? For example, I can ask when the velocity is horizontal, what time the object will arrive to the floor. When it arrives to the floor, what the distance, the range of this projectile? Let's go to try to solve this kind of questions for this problem, okay?
Professor, is Vx you said Vx never changes, right?
Yes.
Vx in just this problem or all of the problems?
In any problem that there is no acceleration in the x direction. Because if there is no acceleration in the x direction, it means that the velocity cannot change in the x direction. In this case, there is no acceleration in the x direction. So in any problem that there is no acceleration in the x direction, Vx is constant.
And constant means in this case 10 or in all cases 10?
Constant means that doesn't change.
Okay.
Doesn't grow up, doesn't decrease. This is the meaning of a constant quantity. For example, if you see your balance account and you don't deposit anything and you don't make checks from this account, your balance account will be constant. Always you will have $1,000. In time, this amount will not change because you have not make any checks. If you make a check, the amount will reduce.
Okay, so in this problem, we were given that V0x is 10 meters per second. So in another problem, if it was 15 Vx, the equation would still be 15. Like it wouldn't change.
You mean at the beginning of the lecture that I put 50 maybe?
No, I'm getting like an example because in this problem, you gave us the values of Vx and you said Vx was 10, yes. Correct?
Yes.
If you give us another problem where Vx is 15, for example, does that mean the Vx is always 15?
V0x, you mean?
Yes, V0x would be 15 in another problem if that was given to us.
Yes, of course.
Okay. I wanted to make sure the 10 wasn't part of like the gravity or something.
Yes, of course. So okay. The four equation that we have is like this. The Ax equals 0. The x of t equal, can you tell me?
In this equation, x of t is 2 plus 10t.
2 plus 10t.
We cannot see what you're writing, Professor.
No? Oh, let me reconnect. Now you can see, right?
Yes.
Yeah? Okay. A of x and Vx of t equal V0x, that was 10. This is my 3 equations for the x direction. Let's go to write the equation for the y direction. Ay equal minus 10. Y of t equal y0 Don't remember. 5. Y of 0. The
Y
initial,
t equals 5 plus 20 times t minus 5t squared.
okay, and By of t will be B0y, that is 20, minus 10t. These are my 3 basics equations. And what I say is that for these 3 basics equations that we have constructed, we can answer any question. For example, can you tell me the time t when, let's go to see the equation. These are the equations, this one and this one. How you will obtain, for example, the time t when y is 0. So it means the time t when the object will arrive to here. How you will do it? Well, you will put y equals 0, and you will have an equation that will read 0 equals 5 plus 20t minus 5t squared. You will apply the quadratic equation, and you will find the time that takes the object in going from here to here. So looking at this equation, you know how to obtain this time. Is correct or not?
We would have to
We will do it.
5bc.
We will do it, but I want you to see if you can catch before doing what we are going to do. Let's say that I ask you, you have this set of 6 equations. I might ask you, can you find the time t where y of t is 0? So you will put 0 here, this will be the equation, and you will solve for the t. And how you will solve? Using the quadratic equation. And you will get 2 values of t. One value will be negative and you will reject, and the other value will be positive, and it will represent the time t that elapsed from the moment that was launched until y is 0. Is correct or not correct? Too silence. Oh, too much silence. Is correct or not correct?
Yes.
Yes? Okay, let's go to do it. But before doing, let me see this equation. If I have this time, the time that elapsed from here to arrive to the floor is y equals 0. Okay? This is the floor. The floor is when y equals 0, when the height is equal 0. When this height is equal 0, is the floor. Okay? If we found this time t, can we find the x, this distance? Can we find this distance, the x from here? How you will find this distance?
I have a question, Professor.
Yes.
So if y goes past the ground, like let's say it goes underground, that's negative.
Yes.
But if it's on the ground, it's 0.
On the ground is 0. If y goes down, it will negative. Let's say that you make t equal 10 seconds. You will see that the y is negative. 10 squared is 100. By 5 will be 500. 20 by 10 will be 200. 205 minus 500, it will be 300 below the Earth. Equal 10 seconds.
Okay.
You catch it?
Yeah, so if it's negative, it's below ground, and if it's 0, it's on the ground, flat.
And if it's positive, it's
in the air?
In the air, up to the ground, okay?
Oh, makes sense, makes sense.
Okay, so if I found this time, the time that elapsed from the object, from the projectile to arrive to the floor, can I take this time and put it here? Yes. And what will I will obtain? The position x when y is 0, because this is the time. So I will obtain what we call the range, this distance, because if you throw with different angles, this will do like this, and maybe it will have different range. You see, sometimes you need the range, a bigger range, especially if you launch a bullet and you want to be hit in someone that is here. Okay? If someone is here and you launch a bullet, you need to make sure that the angle that you throw the ball will be the effective angle, the angle that makes the bullet to arrive to this range. But if you throw with this velocity at different angle, the bullet will not arrive to the desired position. So this equation and this equation will say everything about the movement. That's why we call it the equation of movements. Okay? So I'm going to give you 5 minutes, and I want you to answer the following questions using these 3 equations. One, find t when y is 0. 2, find x equal r, the range, when y equals 0. 3, find t when vy is 0. 4. Find t when vx is equal 10 and vy equals minus 20. And find at this precise moment x of t and y of t. Find the moment when the object have vx equal 10, vy equal minus 20. So it's going in this direction, v. And at this moment, find the x and the y. The y will be negative for sure, okay? Maybe not. Maybe not, because I throw it from some distance from the floor. So,
Professor, could you scroll up a little bit to see the equations?
yes, it's here, no? The equation is here.
Okay, thank you.
So use this equation. This is my problem. Use this equation to solve what I'm asking. I will give you 10 minutes to solve it. And the first one who solved it correctly, please let me know. Okay? I will give you 10 minutes to think. To think is the most important thing that you can do. To think. Some of you, they are used to come to class and they think that because they came to class, they should have learned. No, they learn when they think. And most of the time, they think after class. During the class, you get the feeling, but you cannot finish the class and say, I know what is going on. After any class, you don't know what is going on because your mind have not absorbed the V0. What is V0 and what is V0x and what is V0y? Your mind still is absorbing this knowledge. What is the context of the problem? So you have to think. And I repeat again, do not stop thinking. Do not stop thinking, and I assure you, you will be successful in whatever you do.
Professor, for number 2, x equals what?
For number 2, x equals r, the range. I want to find this range, this distance. That is the distance when y equals 0. I want to find r when the distance, or the distance x, how many meters when y is 0. Okay? Okay, I'll give you 5 minutes or 10 minutes, and we'll do the problem immediately. Did you like the video about the child?
Yeah, I liked it, Professor. I think
Yes.
I like because I think that this boy is doing something that is having a map in his mind and having the history of the map. He knew that Yugoslavia was divided into 7 countries, and he knew where they were, and he knew the names of the 7 countries that they were split. So he started to know many things: history, geography, concepts in the plane, how things move. He's doing pattern recognition all the time. He see a picture, he knows that it's Paraguay. It's something that I really like, and something that I think that you should keep in your mind to teach not only to yourself, to your child when you have it. No, some of you have child, so you start to teach them. Okay. So I'll give you 5 minutes.
Professor, the triangle you drew, is that a -2?
-20. This is the velocity, no? Then,
Oh, it doesn't show everything. It just shows a -2.
sorry, 20.
We still can't see it.
Okay. I said here, Vx is 10, Vy is -20.
X is 10. Okay. And Vy is -20. Thank you.
I would like everybody to put the camera on, please.
Professor, the computer that I'm using right now doesn't have a camera. I'm sorry.
Okay. Ariadna Mustafat is here. Ariadna Mustafa is here, but it's not here. Erline Montpremier. Erline Montpremier is here. Is here. Oh. Janet Garcia is here. Diego Sainz is here. Stefano Ferri is here. Stefano Ferri is not here. And Ariadna Mustafat is not here. But the Zoom is here. I consider anyway.
Do we have to use the same value that you had for for y and x?
For what? Sorry, for?
Do we have to use the same value like for y? Could you say like if y is 0, then so I would know like what would be the initial value, you know?
The initial value is here. Y0 is 5.
Oh, just use those. Okay.
Okay?
Okay.
What I'm asking is what's the time t when the y is 0?
Gotcha.
Okay? I give you 5 minutes. If you get this, there is no problem that you cannot solve. You can solve any problem.
Hola, ¿qué? ¿Qué foto? Ah. Hola. ¿De cuál precio se puede hacer descuento, no?
Salí.
Sí, ma.
Bueno.
Fui a Jumbo Car.
¿Y?
Bueno, el lugar está muy lindo.
Ah, se me olvidó decirte que viera la sede.
Bueno, fue a Jumbo Car. Me dijeron que me lo van a mandar, que necesitan cambiar el nombre. Les di de el recibo y me dieron a mí una copia del recibo.
¿Pagaste algo?
Pagué 740.
Ya lo pagas.
Ya lo pago.
¿Te lo deposito o qué?
Ya mamá me lo depositó. Acaba de salir, acaba de salir. ¿Qué tal?
Bien, vida.
¿Qué tal tu clase? ¿Te acuerdas?
Estoy en clase ahora. Estoy en clase.
¿Pero te escuchan?
Ah, pues sí me escuchan, pero ¿qué importa? No pasa nada. Ok. Okay. Anyone have solved the problems?
I'm on the last one. I'm a little confused, but I'm trying to finish the last one.
Okay, if someone has solved the problem and can show me what he has done in the screen, I will appreciate.
I can show what I did for the first problem, but I did it on a piece of paper, so I would have to like tell you what I did.
Okay, what is your name? Sorry.
Maria.
Maria, okay. Can you show me?
Oh, I can't. I did it on paper.
Ah, you did it on paper, but
But I can tell you what I did.
yes, tell me. Why not?
Okay. So for the first one of find t when y equals 0, I
Yeah.
took the equation of y of t,
Yes.
and I put y of t is equal to 0, and
Yeah.
then is equal to the entire equation.
Yes.
And then I rearranged it so that it could fit into the quadratic equation.
Yes.
And then I solved for t because I solved for t, and I only used the positive value because t is positive.
Okay. And what is the value of t?
I don't know if I got it right, but it's 0.23.
Point
23.
23? Well, you can check it. If you put 0.23 here and you put 0.23 here, it will be the sum
We
with the
can't see
final.
the screen,
It will
Professor.
be 0 or not?
Professor, we can't see the screen.
Oh, sorry. Let me share. I said, you said that the time t where this equation is going to be 0 is at time t 0.23. To check it, you can check if your result is right. We put 0.23 here, 0.23 here. 0.20 is like one fifth. 1/5 squared is 125. 5 between 125 is 1/5, is minus 1/5, plus 20 times 0.23 is 4 meters. Is 4 meters plus 5 meters will be 9 meters, so your time is wrong.
Okay. How about 4.23? Is that one right?
Well,
That's what I got.
Yeah, that's what I
23,
got.
we can check it.
Okay.
4.23, I make it 4.23 here. A square will be like 16, 17. 17 by 5 will be like 50, minus 50, plus 40, plus 80. 4 by 80. No, I don't think it will do it. Let me do it. So the equation that we have to solve is this equation. Let me solve it. Just a moment. Okay, the equation is y of t equals minus 5t squared plus 20t plus 5. Okay, 20t. Okay, plus 5. So it's the same equation that y of t equal plus 5t squared minus 20t minus 5. Is correct or not?
I think it would be correct.
Okay, so what?
Why didn't you write one, Professor? Why is one with the positive and one with the negative?
Well, y of t is equal. So if I put minus y of t will be 5t squared minus 20t plus 5, correct? Minus 5, correct?
Yes.
Yeah.
When I'm looking for the value when y of t is 0, it doesn't matter if it's 0 or minus 0, because 0 and minus 0 is the same thing. So the real equation is this one. But to solve it, I solve it like this. It's easier. Okay? But the real equation is this one. This one. Okay, this one is the real equation. But to solve it, I solve it like this. If you want, I can solve it with the first equation. But the equation is b minus b, that is 20, plus minus the square root b squared, 20 squared, minus 4 times ac, 4 by 5 by 5. And minus minus will be plus here. Okay? Yes or no? Yes or no?
Is it possible that we can still use the equation on the top, the values of a, b, and c? Like,
yes, of course. Let's go to
okay.
do it. Let's go to do it. So I have this equation, 5t squared minus plus 20t plus 5. This is the equation equals 0. So equal, t equal minus b minus 20 plus minus square root b squared, 20 squared, minus a minus by minus is plus 4 by 5, 20, 20 by 5, 125, no?
I put 100.
No.
Wait.
5 by 5 is 25, by 5 is 125. Divide by 2 times a, but 2 times a is 2 by minus 5. 2 by minus 5 is minus 10. So this equation and this equation is the same result. So we follow.
Professor, I still have 100. Because it's negative.
Oh, sorry,
okay, it's like
100. Yes, yes.
Okay,
5
okay.
by 2, 4 by 5 is 20, 20 by 5 is
Right.
100. Yes.
Okay, thank you.
Sorry. No, thanks. Sorry. So we'll minus 20 plus minus a square root. A 20 square is 400, right?
Yeah.
Plus 5 is plus 100 divided by minus 10. So now I have to choose the negative time. This negative is the one that will make me the thing positive. Minus 20.
Professor, can you go down a little bit?
Yes.
Thank you.
Okay. Minus 20. So t will be minus 20 minus a square root of 500 divided by minus 10. So will be 20 plus a square root of 500 divided by 10. It will be, what is a square root of 500? 20 by 22, 23.
22.36.
22.36 divided by 10. So will be 44.30
divided by oh yeah.
Will be 4.4 seconds. So if I plug 4.4 seconds here and I make it the square, and I plug 4.4 seconds here and multiply by 20, and I sum everything with the 5 will be 0. So the time that takes to arrive to the floor is 4.4 seconds, correct?
Yes.
So now that I have this time, I want the x. The x of this time is v0x by t plus x0. So my equation of x of t was, was x0, sorry. I don't remember, 3 meters, 5 meters.
I'm sorry, Professor. The answer for the quadratic formula was 4.336, right?
It's the same thing, 4.4.
Oh, okay. Okay. Also, why did you only use the negative side of the plus and minus sign?
Okay, this
Because it's
question, this
the one
question
that leads
is
to a
a good
positive answer, I
question.
think.
This question is a very good question, but I'm going to challenge you to think it about it. I know that you can solve it why I use the negative and not the positive. So you tell me the question on Thursday, the answer to your question.
Wait, why did you, and then also, why did you cancel out the negative signs? Because you wrote minus 20 minus square root of 500, and then you changed it to 20 plus square root of 500.
Yes, it's true.
Is that a mistake or?
Oh,
Isn't it because
Let's go to that. This will be minus 20 divided by minus 10 plus minus square root of 500 divided by minus 10. So this will be minus 20 divided by minus 20 plus 20 divided by 10 plus minus 500 divided by minus 10 is square root of 500 divided by 10.
Okay.
This is basic algebra for less than high school. So you have to remember these things, okay? It's a basic, very basic algebra. And why, and your question, why I use this negative sign? Why I only took this negative sign? Because I know that if I take the positive sign, when I make everything, the time will be negative. So I reject this solution. This is the answer. So try to use the positive sign and you will see. So x of t, can you tell me v0x, how much it was? 10t, I remember, but I don't remember the x0.
X0 is 2.
2. So this is the equation of x of t. What is x of 4.4 seconds? Is 10 times 4.4 plus 2. What is 10 by 44 plus 2? Equal 46 meters. So x of 4.4 meters is 46 meters. What it means, this 46 meters? It means that the object will arrive in 4.4 seconds, will arrive to the floor, and the x from the origin will be 46 meters. When it arrives here, the time elapsed is 4.4, and the x, the range, what we call the range when it arrives here, it will be 46 meters. Is clear?
Yes.
It's line from here, from x0 equal to, and y0, I don't remember. 5, I put? I don't remember. Whatever. It was launched like this and like this, the projectile, okay? So here, so the second question, there are more questions here. I think the second question is, at what time the velocity is horizontal, no? This is the second question. Can I go down? Going down. 5, no, the second question we already solved it, it's 44 meters. Find the time when by0. Let's go to find the time when by0. I think that we already solved it, but by0. Vy of t is v0y minus gt. So we solve vy of t like v0y. Can you tell me v0y was 20 plus 20 minus 10t. So if I want by of t to be 0, I want that 20 minus 10t to be 0. I want 20 equal 10t, or minus 20 equal minus 20, minus 10t. Okay, so t will be 20 divided by 2. So in 2 seconds, the object will be here. Only using the equation of movement, I have many information. I have all the information that you can imagine. You can ask yourself any kind of question here. You use the equation of movement and you solve it.
Professor, can you go down a little bit and explain what does that say? Is that say? No, wait, no. Wait, what? No, down the other way? No, down. Yeah. Keep on going. Keep on going. Yeah. What does that say, Professor? It says plus 20 equals plus 10t.
Well, what I said is that this is the equation that we have to solve. And this equation is basic algebra. If you make this 20 to this side, it will pass like minus 20, and you will have the equation minus 20 equal minus 10t. But now you can play. You pass this 10t to this side, and you can pass the 20 for the other side, and it will change the chain. So in this side, 10t equal 20. So t is 20 divided by 10. Saskia,
Yes.
you need to review algebra. You need to review. It will help you a lot. You have, I understand that you are studying architecture.
I'm not. I'm a psychology major.
What are you studying?
I'm a psychology major.
Oh, worse. I know that as a psychology, you don't need too much algebra, I know. But for this course, it will be very, very helpful to remember basic things about trigonometry, algebra. It will help you a lot to be faster. So try to see on YouTube some videos that it will help you, okay?
Okay.
It will help you a lot.
Professor, you wrote t equals 20 divided by 2, but isn't that supposed to be 10?
Sorry, is what?
What is, oh, wait. You wrote, on top you wrote t equals 20 divided by 2. Yeah, right there. Isn't that supposed to be 10?
Yes, sorry. Yes, 2 seconds.
Okay.
Divided by 10 is 2 seconds. Sometimes my mind runs faster than how I write. But I write the correct answer, but I don't write the, okay, sorry. Sorry,
is that
but
supposed to be 2SG, or like 2 seconds, like what is that after the 2? All of
2 seconds.
Oh, okay.
2 seconds, 2s, okay.
Okay.
2s. Okay, 20 divided by 2 is 2.
Okay.
Okay, sorry. So I'm going to leave you for your
Wait, Professor, you didn't do the last part of the question.
What is the last part of the question?
To find t when Vx equals 0 and Vy equals negative 20.
Okay, when Vy is 0.
Vx is 0 and Vy is negative 20.
Vx is what?
0 and
No,
Vy.
Vx is never 0. I cannot ask this question.
Well, you did ask it.
Okay, let's go down and we ask.
It was 10?
Yeah.
10.
Oh, it was 10. I'm so sorry.
Because Vx never 0. Vx is 10. It never changes. So you cannot find this position. This,
okay, I'm sorry.
States, no? So we can find t when Vx is 10 and Vy is minus 20. Okay. Let's go to do this. Okay? You want to do this? Or you want to do it as an exercise?
I want to see how you do it.
Okay. When Vx is t and Vy is minus 20. The equation of Fuhrman says that Vx is always Vx, V0x, and V0x is 10. So this, I found it very easy, it's always 10. The question is when Vy, that the equation of Fuhrman is V0y minus gt, when this will be minus 20. At what time t? So I put the equation V0y is 20 minus 10t should be equal to minus 20. This implies that 20 minus 20 will be 10t. So this will imply that 40 will be 10t. So this will imply that t will be 40 divided by 10, 4 seconds. So at 4 seconds, you will find the vector velocity like this. Vx will be 10, and Vy will be minus 20. And the vector velocity will be like this. And
Could you scroll down a little bit?
Sorry?
Okay, thank you, thank you.
Okay, so at 4 seconds, you will find the vector velocity in this state, going like this. And what's the position? Very easy. What is x of 4 and what is y of 4? You will go to the position, to the equation of movement that say that x0 is, I don't remember, by v0x, it is 2 plus 10t. And you will put this time t and you will find x of 4. So easy. So easy. So,
okay, thank you.
So I would say remake again this problem. I don't want, we are how many people now? Because we are now, how many people are here?
Sir, can you go back to the work? I was writing down the notes. Yeah.
Here?
You put y of 4. Are you gonna finish that?
Oh yes, I'll do it. Y of 4 is y0 plus v0y t minus 5t squared. Will be y0, can you remind me what is y0? 5 meters maybe? The initial position where it's launched is 5?
Y0 is 5.
5 plus v0y, I remember is 20t minus 5 of t squared. If you find the y at 4 seconds, you will put a 4 here and a 4 here. So y of 4, let me go here. So y of 4 will be 5 plus 20 multiplied by 5 minus 5 by 4 squared. So will be 5 plus 80 minus 16 by 5, 5 by 16. 5 by 16 is 85 minus 44 will be 41. Plus positive, impossible.
What?
Yes, it's possible, yes. It's possible because it arrived at 4.3 seconds. No, you told me that it arrived to the floor at 4.3 seconds, no? So 4 seconds is before it arrived to the floor. So the y is positive, 41 meters. Okay?
Yes.
So I would say remake this easy problem again. You will catch up the detail if you remake it by yourself. And once that you remake it, you start doing all the homework about projectile motion and falling in gravity, freely falling objects. Okay, that is the same equation. It's exactly the same equation. The only difference is that in a free falling body, the x doesn't work. The position x doesn't work, only the y and the vy. So I'm going to give you until Thursday to finish the problems that are already in the unit 3. And to say goodbye, let's go to see something. Let me see something.
So all of unit 3 is due Thursday?
Yes, please, please. I beg you.
I thought you said it was due Tuesday.
If you need it by Tuesday, I will tell you. I will do it. But please work until Thursday. I'm telling you, work for Thursday this problem. You can do it by Thursday. If you cannot do it, I will consider it to put it until Tuesday. But why I'm begging you to do it before Thursday. Because on Thursday, I'm planning to start with Newton laws. So if I start with Newton law, I would like that in your mind you finish this unit 3 and we start with unit 4 in a fresh way with a, you know, I think, but if it arrives Thursday and you are under big pressure, do not worry. Do not worry at all that I will tell you, I will extend it, okay? So,
Professor, what's going on with the?
Yes.
What's going on with the quiz? Is it
The quiz, you will receive it. You will receive
Que
it.
vuelvan los besos, las risas, las voces y los bares llenos, los gritos, los goles. Que vuelva el abrazo.
The quiz, you will receive it in a few hours, okay?
Okay, thank you.
You start to do it, you will deliver before 12 o'clock, okay?
Okay, thank you.
I have a question.
I leave you with this song to relax so you can do the quiz in a relaxing way.
Professor, what song is this?
Canta y no llore, que lo malo se va en un suspiro, que amargarse no vale la pena, que la vida está llena de cosas bellas, que le dan sentido. Canta y no llore, que lo malo se va en un suspiro, que amargarse no vale la pena, que la vida está llena de cosas pequeñas. Que le dan sentido.
Professor, what is the name of this song? Professor.
Yes.
What is the name of this song?
I don't know.
Okay.
But you like?
Is class over?
Yeah, it is.
Okay, thank you.
Professor, I have a question.
Que vuelva la brisa al que hacer la rutina y arreglar el mundo en el bar de la esquina. Que vuelva la música en vena, vuelva la alegría y se vaya María. Que lo malo se va en un suspiro, que amargarse no vale la pena, que la vida está llena de cosas pequeñas que le dan sentido. Canta y no llore, que lo malo se va en un suspiro, que amargarse no vale la pena, que la vida está llena de cosas pequeñas. Canta y no llore. Que la vida está llena de cosas pequeñas que le dan sentido.
Okay.
Professor?
I wish you a happy afternoon doing the problems of the exam, okay?
Professor, I have a question.
Yes, ask me.
You said that the quiz was going to be given to us later, but I have
Yes, give me 1 hour and I will post it, okay?
Okay, because I have class from 6 to 10 o'clock at night.
Well, you have until 12 o'clock. If you need more time, you let me know and I will open for you.
Okay, thank you.
Okay, if you want, yes, you tell me, and if you really are in pressure, you tell me and I will extend it until 1 p.m., okay?
Okay, thank you.
Professor, I have another question. What is due Thursday that you said was due Thursday? I thought that was the quiz.
No, Thursday is the unit 3.
Oh, okay.
The quiz is tonight, until tonight. Okay, I want to do it tonight. Not
And
to- okay.
when is your first exam?
When is
The first exam.
the first exam will be probably not next week, the other week, the following week, because I want to end it between Thursday and Tuesday. I want to end Newton's law. Once that we finish Newton's laws, and I'm sure that you have learned Newton's law, we will do the exam of Unit 1, Unit 2, Unit 3, and Unit 4, that will be Unit Newton laws. And this will be the first test, okay?
Okay, thank you.
Okay. Okay. It's okay?
Yes, thank you, Professor.
Okay, so good luck, enjoy, and be happy.
You too.
Okay, bye. Bye-bye.
Hello, Professor.
Yes.
Sorry, I have a question. I sent you an email asking when the test was, and I just saw that you replied, but you told me that the test was tomorrow.
What
you mean
test? What test?
Because I said, like, I asked when our first test was.
No, tomorrow, no, not tomorrow.
Oh, okay, okay. I was just clarifying because I just checked my email.
No, for sure no. Okay.
Okay.
Okay, let me see here. Let me see here. Okay. So okay. Okay, I'm going to disconnect. Okay.
All right, Professor. And I'll email you later on tonight when I get out of class. Hopefully you don't have to extend it, but will you be checking your
I
email?
have a question.
Yes, I will be checking.
Professor,
Do not worry. Do not worry.
question.
Okay. Yes. Yes. Any other question? Any other question? Any other question?
Question.
Yes.
Okay, so I have the one that was supposed. Can you hear me?
Yes.
Hello?
Yes, I'm hearing you.
Professor, can you hear me? Hello?
Yes.
So, okay, so I have a question about the homework today, and then
Sorry,
I have a
your voice.
question because the
Can you start again?
thing is that I have
I'm not hearing you. I'm not hearing you. Maybe write on the chat. Hi. Matthew. Okay. I'm going to end the chat, okay? Okay, any other questions?
Yes, Professor, can you hear me?
Yes, Stefano.
Hi, sorry. I'm currently in Europe and here it's already 10 p.m. I was going to ask you if it's possible for you to post a quiz a little bit sooner so I don't do it too late.
Of course, of course.
Thank you so much.
Okay, I will give you more time to you, okay?
Thank you so much. Appreciate that.
Okay, enjoy Europe. In what part of Europe you are?
I'm in Italy. I'm coming back to Miami next Saturday.
Okay, so take care of
Thank you. You too. Thank you.
Okay. Any
Bye-bye.
other question?
Professor, around what time are you gonna release the quiz?
As soon as possible, maybe 1 hour.
Okay.
You will receive a notification soon, okay?
Okay, bye.
Bye.
Professor, I'm sorry. I have one last question. I have zeros on the homework, but I wasn't sure if like those were
I
zeros.
did not start to,
Oh, okay. Like you didn't
grade the
grade.
homework. I'm just
Okay,
watching and reviewing the homework without putting any grade. So give me some times that after test 1, I will put all the grades. Okay?
Yeah, no, don't worry. Take your time. I was just worried because I saw those zeros and I was like, oh my god, I get zeros.
No, everybody have the 0. Everybody. It's not. Okay.
Okay, thank you. Bye, Professor.
Bye. Any other question? No more questions? Okay, can I leave? Can I leave? Can I leave to make the quiz? Okay, bye. Thank you.
Bye.